as well. So hey everyone, thank you for coming to my presentation titled Originlens, a real-time AI-generated text and plagiarism detection using deep learning and augmented reality. I'm really honored to be here today, and I'm really happy to be able to share the work I've done in the past couple of months. And so first, before we get into what my paper is about, we have to go through a little bit about the history. So what really inspired me to do this paper was essentially the growth of ChatGPT. ChatGPT has really been an important part of our society in the past couple of months, seeing how we've reacted to it and seeing how we've grown to adopt it into our daily lives. And ChatGPT was actually isn't exactly a new invention. It's been around for a pretty long time. The parent company, OpenAI, was actually founded in 2015 and had released a couple of demos and other models in the past couple of years, such as GPT-1 and GPT-2. However, those weren't exactly the level of ChatGPT now. At best, what they could do was generate some pretty primitive phrases and weren't exactly up to standards that most people were looking for in a good AI generator that we have today. And really, it didn't really grow quickly, and not a lot of people even knew what a ChatGPT was. That all changed in December of 2022. Basically, that's when GPT-3 released the first demo model for GPT-3. This was one of the most advanced models out there for AI generating text, and it was one of the fastest growing apps in history. It took only 5 days to grow to 1 million users, which was substantially more faster than any other app in history. And and it also was the quickest app to grow to 100 million users, as people quickly realized what the potential was for such an app. And so GPT-3 is really unique because it was trained on significantly more parameters than any other model before it. It trained on 175 billion parameters and was the first AI generator to be deployed in widespread use. Before this, we've never seen anything like it. And recently, in March of 2023, the next model, GPT-4, released, which was another massive leap in the advancement of quality and also had significantly more parameters to use. And so today, ChatGPT has never been more advanced. It has never been more reliable, functional, and fast, with new updates coming out each month or week that changes how we see this app, and also new functions such as being able to generate images and read images and things that would have not been possible a couple of years ago. So in order to understand what ChatGPT is, we also have to know how ChatGPT works. ChatGPT is basically essentially you can think of it like an autocorrector. If anyone has used Google Docs before, if you've, for example, type in a few words that like the beginning of a sentence, it sometimes can finish it for you. So like it predicts the next word and like grayed out text. Once you press tab, it fills in that text for you. That's basically what ChatGPT is. It uses a model called the transformer architecture, which is basically very suited for a conversational generation. And basically what it does is it takes in the prompts that you inputted and it predicts what the next word will be based on what the previous word was and the prompt. And then it just continues to generate words like that. That's basically why if you use ChatGPT today, you see that it doesn't generate a huge chunk of words all at once. Instead, it generates word by word, string by string until it finishes the sentence, which is why it generates like that, and also why it sometimes can be slow because it's running the algorithm in real time, as opposed to having a predetermined generated text. Yeah. So, and also, this method of generation provides some advantages and unique opportunities. Because of the limitations of this architecture, it can be possible to analyze patterns which can exist in the generated text. And yeah, like I said, it's really similar to Google Docs, but instead of having having to predict what the next word is, it instead takes into account billions of sources that it has, the billions of models that it has, and uses those to try to predict what it is. So problems in ChatGPT include educational and in daily life. So in certain ways, ChatGPT creates a sense of complacency and reduces the motivation to learn. This is a real big motivator for why I decided to do this project, was because most people, especially in school or whatever, they would uh, they would have less of a reason to learn, as they would normally think that ChatGPT could do it for them. This is a really big problem because that defeats the whole purpose of learning and reduces the amount that people are willing to learn. And also another big problem is ChatGPT can sometimes make up information. It isn't exactly 100% of the time, but if you ask something of it that it doesn't have a source of, it sometimes can make up information that it thinks that sounds extremely correct because it presents it in a way that sounds correct, but it's actually not correct because it is trying to just fill in the gaps that it has. And it also even warns you on the website that incorrect information is possible. So why it matters. So high amounts of usages in areas such as high school makes it a very prominent issue. Even elementary schoolers and really young people realize the potential of ChatGPT, showing how deep this issue can be in our society and showing the kinds of people that are trying to use it. With the amount of work that ChatGPT can save, many people find themselves purposely procrastinating because they realize that ChatGPT is an option that they can use. Because it takes significant amounts of effort to write meaningful text, such as academic writing, uh, this can be cut down to seconds or at most minutes using ChatGPT in certain cases. And that just promotes procrastination. And also, this isn't exactly related to academic fields, but also the existence of ChatGPT creates a sense of this creates an environment, a negative environment, where most good pieces of writing can sometimes be flagged as actually being AI by some people, as they think that most quality works of writing are AI writing. That's a very unhealthy environment to live in because that sometimes cannot be true. And it could just be possible that some people write very similarly to ChatGPT. And the idea that if you write a good quality piece of text, you actually used ChatGPT it's just something that is another issue. And also um, and also when if you use a detector, some people can have incorrect assumptions that can lead to punishments, which is very possible because if an AI algorithm were to give an incorrect result, for example, you have a piece of text, a piece of writing that is uh, flagged as by someone as being an AI when it actually is a piece of original work, it can lead to significant consequences and it has the potential of ruining someone's academic career. And that is something which needs to be avoided through an algorithm which is accurate at predicting most of the time. So fake pieces of writing written by ChatGPT can also have the potential of spreading misinformation. And due to the professional nature and how confident ChatGPT sounds at writing fake information, it can really reduce the public trust in info and can also even spread false ideas that are actually incorrect. So some examples of this is if you generate a fake government notice that seems genuine, for example, like an evacuation warning, uh, with ChatGPT generated text that sounds almost like the same, that almost sounds real. Um, it can be very dangerous because it causes a significant amount of chaos and other things that could occur. So possible solutions, like I mentioned earlier, because of the algorithm ChatGPT uses, there can be ways to detect its generation, and you can use the patterns that exist within the way it generates text to see if something is AI writing. So, for example, ChatGPT tends to repeat certain words. This is because it wants to emphasize certain things. In academic writing, the word student is repeated significantly more than any other word. That's because it wants to sound confident in its writing and repeats the role of a student quite often. So by counting the prevalence of certain words and using other analyzation methods, it's possible to analyze the common repetitions to influence results. And just like how ChatGPT uses an algorithm to predict which word is used next in building a sentence or a paragraph, we can reverse engineer this process basically to see which word it prefers more. And that is basically the method of detecting that I used. So some issues, although this method of decomposing how ChatGPT generates words is a reasonably reliable way, it can be difficult predicting really obscure prompts that aren't fully present or expressed in a data set. Along with this, the rapid evolution of AI can make this obsolete relatively quickly, meaning that more data gathering will be necessary to keep up with standards. And in the future, it also could be possible that the transformer algorithm that these AI generators used can be dropped in favor of an unpredictable way of generation that doesn't have the patterns that a transformer algorithm uses. And yeah. Also, there can be ways of getting around AI detection. So, for example, using a summarizer, summarizing in the style of a human do exists, and it's advanced enough to the point of being almost unrecognizable. Or you can also just use something, or you can also just put this through ChatGPT so many times that it's almost impossible to discern a recognizable pattern, as the probabilities of the words it generates are scrambled and it's not conclusive enough to formulate a conclusion. And the last and probably the most common occurrence is to just rewrite AI generated text in your own words, basically similar to summarizing it, but instead using the ideas that ChatGPT presents, which are sometimes not your own, in your own style, so it avoids detection. And these all are ways to reduce the possibility of detection, and most of the time they are successful. So there's also blatant detection. Without the use of an algorithm, some people can also just see if something is AI or not. This is an easy process, especially if you use words in the prompt such as detailed. It tends to use very complicated words that are usually not up to not us that are usually not the level of the writer, especially in lower grades such as high school or middle school. And it can be easily told if something's written by AI. Also, the grammar used in ChatGPT responses are almost impossible for regular people to know without the use of a dictionary. And it's really hard for these words to be used by most people, other than very high level English students, for example. But in most lower level schools, it's not exactly a common occurrence. So it's very simple to detect whether something's written by AI or not in those cases. In harder cases, though, it's a little bit more difficult. So my research goal was to just first be able to develop an AI writing detection platform using machine learning and OpenAI's API. And then finally, this was another problem that came up that I came up with a solution with, was to integrate it into augmented reality, which would just streamline the entire process and allow for real-time usage along with OCR also known as optical character recognition. So my technical topics, these are the topics that I used to develop this algorithm and the parts that I highlighted as the most important. The first one is NLTK, summarizers, tokenizer, stop word removal, and cosine similarity were all vital to this algorithm. And my first part is the summarizer. So the summarizer is basically a way of reducing the difficulty of and costs of using OpenAI's API. So OpenAI, if you use its API, it's really expensive in certain cases, especially with more advanced models such as GPT-4. In some cases, when testing with more expensive models, I utilized NLTK summarizer to reduce the cost possible because of certain prompts. If the prompt is more complicated, it will return a result that is more complicated along with it. So that's why if you summarize a really advanced prompt, it will give a more basic and generic response and just reduce the cost by a significant amount. This isn't necessary, but if you want to reduce the costs while still retaining most of the knowledge, this is a good way to do so. So for example, here, if you have a topic such as school uniforms, like school uniforms are often seen as a way to limit individual expressions and all of that. If you use the summarizer, you can simplify it to, while this might be true in certain cases, it's important to remember that uniforms are not only about the clothes themselves, but also about the values and standards that they represent. Basically, you're shortening the prompts to a significant amount and just reducing the unnecessary parts and getting to the main idea at once without using an introduction. Since OpenAI is advanced enough to recognize what this entire topic is about without the parts that it needs, such as specifically stating it's school uniforms, um, because in the simplified version, it's still talking about uniforms, and it naturally assumes that they're talking about school uniforms because this is an academic prompt. So tokenizing is basically allowing you to split up text or by the sentence and allows you to identify words that come up really often. For example, if you have a sentence or a group of words, but you might find that certain words pop up more. In this case, my analogy is if you're going through a bunch of coding job advertisements, the word such as Python or any other language pops up a lot because that's what they're looking for and that's what their demand is. It's really specific to coding job ads because they require it more, but you can analyze these patterns to see what they value more and what is less valued or what is more valued. And if you, for example, use tokenizing in a sentence, you can see how these words relate to one another and seeing how that adds more context. So if, for example, if you analyze a sentence, you can see that if a lot of negative words are used around the word Python, it's probably because something is less valued. You can use these patterns to really see if something is true or not, and just use tokenizing as a very valuable tool to recognize these patterns. So the third part, which I really valued, was removing of stop words. Stop words is another topic which is similar to tokenizing, but instead of analyzing the structure of sentences, you're instead removing certain words. These words are basically essential parts of grammars that don't add any meaning to a sentence whatsoever. So words such as the, in, is, and, they aren't exactly necessary. I mean, they are necessary in adding a grammatical sense, but they aren't exactly exclusively used to, for example, human or AI writing. They both requires the usage of these stop words in order for a sentence to make sense. So if you remove it, you're technically not losing anything at all in terms of grammar, in terms of meaning, because these are just parts of grammar that are just unnecessary at all. So it doesn't affect the meaning of the sentence, but it makes more sense to add them in if you're trying to read it. So that's basically what stop words are. And so the second part was the more mathematical part, more mathematical functions. So word frequency, TF, IDF scores, and cosine similarity. Um, the first part is known as word frequency. This is basically a pretty simplified way of tokenizing. Uh, what I basically did with my data set was I used OpenAI's API and then used Kaggle's API to pull examples of uh, AI writing and human writing. Uh, and I implemented the things I just described, such as stop word, removal of stop words, summarizing, and sometimes tokenizing in order to make a data set that was necessary for analysis. And then I implemented word frequency, the TF-IDF scores, and cosine similarity. So word frequency is just a way of tokenizing, and it just measures how many the most common occurrences of certain words. So like I mentioned earlier, the word students appears really often because this is this is an academic data set. And as you can see on the right, this is the top right is word frequency. These are the words that popped up the most in my data set and are likely the most common words that AI tends to use. And then the TF-IDF score is pretty similar to word frequency, but instead of measuring the relative appearance, it more uses the ratio of a certain word to the rest of the sentence or data set and uses that score to measure how much something appears relative to everything else. Not exactly counting up the appearances, but rather the relative occurrences. And once we've gathered those numbers, we can use them for analysis. The way we analyze this is using cosine similarity. Cosine similarity is basically a way of saying yes or no to something. It's really similar to a voting classifier. And basically, after we find those numbers from word frequency, it then takes in two data points. One data point is the data set it trained on, the numbers that it used from the word frequency and TF-IDF. And then the second data point is the example being tested on. So think of item one, for example, here as the numbers returned from the data set, like the word frequency numbers, for example, and item two as the experiment. The distance between these two data points are the cosine are known as the cosine similarity, and this number is the probability of how likely something is of being AI generated. So implementation, after gathering this algorithm, I decided to do a couple methods of implementing this. The first one would be a website. A website is probably the most simple way of deploying this in order for simplified use. It allowed for an easy access and easy time using with an HTML front end and a Python backend. And it allowed for results to be easily displayed by just copy and pasting a sample inside of the box over here. And once you press the classify button, it just shows you the probability and how likely something is to be AI generated or not. That's the whole idea, but there are some limitations to this idea. This is only exclusively limited to online text detection. So if you have a piece of writing that's online, it could be possible to use this because you can just copy and paste it. But it's really difficult to do something on paper. For example, if you have a school project that is exclusively turned in on paper, you don't have access to their online resource, so you can't exactly copy and paste it into this website. So you have to either manually type in the entire body of text or use the second implementation I used, which I will talk about. And that is optical character recognition. Optical character recognition is the act of pulling text from a camera, and that allows for my algorithm to run through these words that you pulled from the camera. There are some limitations that can exist, especially because OCR technology can be limited in certain scenarios, especially with camera quality and some different and some different environmental factors that can affect accuracy. But I tested it and it was relatively good at detecting certain words. But it also sometimes misread specific words, and it also could have accidentally missed a word too. This is always possible, especially with the relatively new technology that is optical character recognition. And I decided to host this on to a Raspberry Pi with a USB camera since it was simpler to travel around with, and also could be very convenient to have a little portable device with you instead of being specifically restrained to a personal computer, for example, or a laptop. And then the last part is augmented reality. Optical character recognition is good and all, but you need a constant image to be shown in order for this to be useful. And the last implementation I decided to do was augmented reality. This is this is more of like a prototype, doesn't really work very well yet. I'm still like researching a little bit more on this. But basically what you could do is wear this on your glasses theoretically, and it has a camera feed, and you can analyze text in real time without needing to use any hands or for example like that. And this device right here is just based around an old Epson Vario. Uh, those were really old drone glasses that were developed in the early 2010s that weren't particularly successful because they were really restrained in only the drone field and weren't exactly very developed. And I tweaked it a little bit because of proprietary reasons. The display that they used is known as a micro OLED. It's a really new piece of technology. Well, it's not really a new piece of technology exactly, but it's a pretty proprietary piece of technology that Epson really developed in order for this. But because of this, they locked it behind some proprietary technology, like the the display connector they used was uh, completely different from any other ports that anyone has. And so I just removed it and decided to implement my own version, uh, which is basically a new display found on AliExpress, which contained an HDMI connector, which you could easily use because most devices have an HDMI port. And yeah, this is basically the augmented reality portion. And so after I implemented this, I decided to do some experimentation. So my first piece of experimentation was done with AI samples pulled from ChatGPT at a reasonable accuracy. This is displayed in the form of a confusion matrix. Confusion matrices basically have two axes. One is the predicted and one is the true. Predicted is the algorithm thinks is true, what the algorithm returned, and the true label is what it actually is. So as you can see here, there are some possible reasons for an incorrect result, uh, and that most likely is due to overfitting. And I decided to see if this was also shared when I used human experimenting data points. And that is my second experiment where I essentially used a couple of pieces of human writing and I tested the accuracy. It was relatively good at detecting if it was human writing or not, with some possible areas for improvement. And I decided that it was possibly a case of either not enough data or overfitting. So I just corrected those by adding more diverse data sets of various lengths. And I did a final experiment. So my final experiment, I used around 300 random samples that I pulled from random sources, such as unused data points from my original API calls. And after running it, I saw that the accuracy was around 97%, which is sufficient enough to prove that it's useful, but there are still some cases of incorrect results. So improvements that you can make to this is, of course, enriching the data set. This is the most vital portion of the algorithm as it hosts all the samples that it analyzes. Because this data set was focused primarily on academic writing from the lengths 150 to 200 words, introducing various lengths that aren't restricted to 150, 200 words and more diverse prompts other than academic topics is necessary for better accuracy. So, for example, if you have more data on topics about like history, for example, that are purposefully longer in the forms of like essays, it can also be more accurate when you input a prompt that is an historical essay of a longer length. And also the limitation is the model that was used to generate the data set was GPT 3.5. This is the most common model used out there, so this is why I decided to use it. But there are some issues because you can technically use other models, such as like Bard, for example, or GPT-4, or just regular GPT-3. And the different algorithms within those different models can also throw off the accuracy if you do that. So to improve this, like I said, would be to add more data. Another improvement that I thought of was you could technically separate algorithms specifically for the length of words. So for example, if you have four algorithms, each for analyzing different lengths of text, such as one algorithm specifically for analyzing words, like analyzing words that are less than 50, or and another algorithm for, let's say, 100 to 150, and then another algorithm trained on 200, and another algorithm trained on 500 plus. You can definitely separate and specifically train those models on different lengths to improve the overall accuracy. Since if you generalize the lengths of words in an algorithm, it typically reduces the accuracy in all cases, but also improves the ones that they are missing from. So instead of generalizing, focusing more on these limitations and separating them can definitely improve the accuracy drastically, and also using different models to do so. So final thoughts, I had a great time doing this project. It was really interesting because before this, ChatGPT was like some, I guess, magical being out there that could generate words at will that were like of exceptional quality and of great length. And to understand something is to be able to know what it does and how it works. So I decided to do that. And this definitely helped me to understand that and how it generates, and also different ways that you can counter its effects by analyzing these patterns. And also, I learned a significant amount about data science and other topics like that, along with other technologies such as Google character recognition and augmented reality. To conclude, just I had a great time learning about this and uh, and other topics that had to do with AI in specifically. So does anyone have any questions?